Okay, today we'll be looking at equation of lines. All right, so these are the forms of the equation of a line. We have slope-intercept, which is y equals mx plus b, where m is the slope and b is the y-intercept. We also have point-slope form, and it is y minus y1 equals m times x minus x1, where m is the slope and y1 and x1 and y1 are points on the line. Standard form, ax plus by equals c, where a is positive and something else has been left off here. A is positive and a, b, and c are also integers, so that's also very important. A, b, and c are also integers. Intercept form, and this is a form that we rarely use, or we will not use in this course often, I should say. So we have intercept form where we have x over a plus y over b equals 1, where a is the x-intercept and b is the y-intercept. So this is something that's not commonly used in coordinate algebra, so you don't have to worry about that this course. And then we have those vertical lines. So a vertical line looks like x equals some value. A vertical line with a is the x-intercept. And a horizontal line where y equals b, where b is the y-intercept. So it's just y equals a value and x equals a value for those. So let's do some examples now. All right, so it says, write an equation in slope-intercept form of the line having the given slope and y-intercept. So this should be easy. Oh, I forgot to get my pen. So slope-intercept form, let me change my color, is y equals mx plus b, where m is the slope and b is the y-intercept. So for number one, I'm just going to plug in what I have. That's all I have to do, right? So I have y equals 2/3 x, and then my b is negative 10, so that's going to be minus 10. That one was nice and easy. The second one is a little different because I do not have my y-intercept. So I need to find out what my y-intercept is. I can do that one of two ways. I can either use point-slope form, or I can use y-intercept form to solve and find out what b is. So I'm going to do two different ways for these two different problems. So the first way I'll use my y-intercept form, and the second way I'll use my point-slope form. So for the first one, again, I'm going to use this form here, and I'm going to find out what b is. So I'm going to plug in what values that I have. So I have x1 here, an x here, and a y here. So I'm going to plug those in. So my y is equal to negative 1/2 equals my slope, which is negative 7/9, times my x, which is 0. And then I have plus b. So this crosses out, right, because it's times 0. So I get negative 1/2 is equal to b. So now I have my b and I have my slope, so I can plug that in. I get y equals negative 7/9 x minus 1/2. All right, so now let's use point-slope form for the for the third one. So we'll use that. We have y minus y1 equals m times x minus x1. All right, so I will plug in what I have. So this is my x1 and this is my y1. So I have y minus 0.025 equals 4.5 times x minus 0. All right, so I didn't even have to put that minus 0 there because minus 0 is just plain old 0. So I can, I'm going to have to change colors, or I'm going to erase what I have here so that if you need to go back and look at it, please just rewind the video, but I'm going to erase it so that I can have more room to write. All right, so I'm just going to pull this up here. So I have y minus 0.02. Oh, no, that's not 0.25. That's just plain old 25. I'm sorry. If I had a student here, I know they would say, hey, Dr. Kate, you made a mistake. All right, and I'm just going to have 4.5. I don't need that minus 0, right? I don't want to be redundant. So I'm not going to be. So I'm going to have minus y minus 0.25 is equal to 4.5 x. And again, I want it in the y equals mx plus b, so I need my y to be by itself. So I'm going to add 0.25 to both sides. That goes away, and I get y equals 4.5x plus 0.25, or 25 hundredths. All right, let's go to the next one. It says write the slope-intercept form of the equation of each line. That is, get the equation to y equals mx plus b by solving for y. All right, so I have 12x minus 5y, similar to what we did just right before. We want to get y by itself, so I'm going to subtract 12x from both sides. That's the first thing I'm going to do. And I get negative 5y. And I want it in mx plus b, so I'm going to put my minus 12x first, plus 18. Then I got to get rid of this 5, or actually it's a negative 5. So I'm going to divide both sides by negative 5. So everything over here needs to be divided by negative 5. So that's going to cross out, and I get y is equal to negative divided. And each one of these, it has to be divided by negative 5, by the way. So a negative divided by a negative turns to positive. So that's going to give me 12 over 5x, and it's perfectly okay to leave it in fraction form. And I have and this is going to be a positive and a minus, so that's going to change to minus 18 over 5. And I can't reduce that any, so this is going to be my final form. All right, so let's do the next one. So I have y plus 5, and I'm solving for y. So over here I need to go ahead and distribute, right? So I'm going to distribute this negative 5 over 2. So that's going to give me negative 5 over 2x. And negative 5 over 2 times minus 2 gives me a plus 5. So now I need to still get my y by itself. So I'm going to add 5 to both sides. So that crosses out, and I get y equals negative 5 over 2x. 5 and a 5 are like terms, so I can add those, and I get 10. So now it is in my slope-intercept form. All right, next let's do point-slope form. This should be very easy. If you recall, point-slope form is y minus y1 equals m times x minus x1. All right, so I have y, these are my points here, minus my y1 is 3 equals my slope, which is 1/2, times x, and then my x1 is negative 1. It's supposed to be minus, so a minus, since in the minus, it's going to give me a plus. Okay, so there it is for the first one. The second one, again, we have y. I have a minus negative 3, so that's going to give me a plus 3 equals negative 7 over 2 times x. Then I have a minus a negative 2, so that's going to give me a plus 2. Okay. Okay. All right. Now it says write the slope-intercept form of the equation of the line described. So slope-intercept again is y equals mx plus b. And so the first one, it tells me that the line is parallel to y equals negative 2x plus b, which is also in slope-intercept form. The slope for this one is negative 2. We know that when lines are parallel, that their slopes are equal to each other, so they are the exact same slope. So I need to take this and use it for this line here to find out what my b is. So again, there's two ways we can do that. So we can say y, oops, actually I'm going to plug in what I have. So this is my x and this is my y. So it's -1, plugging it into this formula, equals -2 times -1 plus b. And I want to find out what my b is. So that's -1 equals 2 plus b. I can subtract 2 from both sides. And I get -3 is equal to b. So my equation is y equals -2 x minus 3. All right, the next one, it goes to the point 0, 0, and is perpendicular to x equals 0. So when it's x equals 0, if you recall from our first slide or from our acronym Bucks Hoy, we know that if it's x equals 0, that the slope is undefined. Well, perpendicular to that will give me a slope of 0. So the slope has to be 0, right? Because I wanted to hit perpendicularly at a 90-degree angle. So that means that the slope has to be 0. So my m is equal to 0. It goes to the point 0, 0. So that means that if I find out what my, we can plug in our values to find out what b is. Hope you see that it's 0, but we'll do it anyway. So 0 is equal to 0 times 0 plus b. So that means that b is equal to 0. So we plug it into our equation, we get y equals, my slope is 0, x plus 0 for my b. 0 times x is 0, and 0 plus 0 is 0, so y equals 0. So there we have it. All right. Last but not least, it says write the standard form of the equation for each line given the slope and y-intercept. That is right in the form of ax plus by equals c, where a, b, and c are integers, and the coefficient of a is positive. So we talked about this before. Let's do it. Let's put it in slope-intercept form first. So that's going to give me y equals 3/4 x plus 4, right? Because that's my b, my y-intercept. I'm going to move my x to the other side. So it's going to give me -3/4 x plus y equals 4. And all I did was, and that's actually going to change it to positive. I apologize. I should have wrote it out. All right. So add 3/4 x to both sides. And so now it's in fraction. It has to be an integer. So how can I get rid of this fraction here? I need to multiply everything by 4. So when I do that, I get 3x plus 4y equals 16. And so they're all integers, and a is greater than 1. It's positive. I mean, sorry, greater than 0. Let's do the next one. So we have y equals 1/3 x plus 2. I'm going to subtract 1/3 x from both sides. This time I'll write it out because I want that to be equal to c, right? I want it to equal c. So I get -1/3 x plus y equals 2. Now I need to, first of all, I need to multiply by a negative so that it's positive, so that the first term is positive. And I need to multiply by 3 to get rid of that fraction. So I'm going to multiply everything by -3. And when I do that, I'm going to come up here. I get positive x minus 3y equals -6. And I hope that this helps.